All right, in this video, we're going to tackle section 3.3, number 53. Find constants a and b such that the function y equals a sine of x plus b cosine of x satisfies the differential equation y double prime plus y prime minus 2y is equal to sine of x. And so in this case, what we're going to do is we're going to assume that y is equal to that summation of trig functions. And then we're going to go ahead and find its first and second derivative and plug it into this equation and figure out what would those coefficients a and b have to become so that this equation would be true. So again, we were given that y is equal to a sine of x plus b cosine of x. Well, that's going to imply that y prime is equal to a times the derivative of the sine, which is the cosine, plus b times the derivative of the cosine. Well, the derivative of the cosine is a negative sign, so be very careful there. And then the second derivative, see, a times the derivative of the cosine is going to be a negative a sine. And a negative b times the derivative of the sine is a negative b times the cosine. Now what we're going to do is we're going to take y double prime, which I'll highlight here, and we're going to take y prime, which I'll highlight in blue, and we're going to subtract 2 of those y's here, and this time I'm not going to highlight it. Instead, I'm going to say, let me put a little stop over there or something. Okay, I'm going to go ahead and say negative 2y, because I didn't want it to look like I'm subtracting 2y. Negative 2y is equal to, and I'm just going to multiply both sides of this equation here by negative 2, equals a negative 2a sine of x minus 2b cos of y, or x, sorry. And so now I'm going to go ahead and take this negative 2y and add it to that blue equation and to the highlighted yellow equation. That should become a sine of x. Well, let's see. Y double prime has this negative a sine, and so I'll write that down, minus a b cosine, plus y prime, so plus a cosine of x, minus b sine of x. And finally, minus 2y, and again, I'm stealing all the information from there. It's a negative 2a sine of x, minus 2b cosine of x. And before I write what it's supposed to equal sine of x, but I'm just going to go ahead and compress things down here. And I'm going to gather like expressions. So, for example, all the stuff with the sign. I have attached to a sign here, I have a negative a, I have, let's see, a negative b, I also have a negative 2a. So really I have a negative 3a and minus b. That's how many signs I have. So let me go ahead and write that. Negative 3a minus b, and that'll be sine. And then as far as the cosines, I have a negative b of them plus a of them, and then minus 2b. So minus 3b plus a of them. Let me go and write that. So plus a negative 3b plus a. Actually, I'm going to say a positive a minus 3b because I like it in the alpha numeric order. And that is supposed to be times the cosine. And all in all, that is supposed to turn into this right-hand side, sine of x. So that is supposed to equal 1 sine of x. There's actually no cosine of x's. If you take a look at that right-hand side, excuse me. So what we're going to do is called comparison of coefficients. So I'm going to take a look at the coefficients of sine. This guy and this guy. They should be the same. 1 should be the same as negative 3a minus b. And I'm also going to look at the coefficients of the cosine. This guy right here is supposed to be the same as that guy. So really, in the end, all told, I should have a negative 3a minus b equaling 1, and I should have a positive a minus 3b equaling 0. And if you look at that, it's a beautiful system of equations from our good old Algebra 1 days. So I'm going to go ahead and multiply that the second row by 3. Remember, when you multiply an equation that's within a system by a non-zero number, which we are doing, we're multiplying the second row by 3, so it becomes a 3a minus 9b is equal to 0. But when you multiply a row in a system by any non-zero number, that's the solution to that system does not change. All right, so let's go ahead and add these up. A's cancel, and you get a negative 10b is equal to 1, or in other words, b is equal to negative 1/10. And now you back solve, right? So if b is equal to negative 1/10, then a minus 3b being 0 would imply that a is equal to a negative 3/10. So there we go. Don't lose track of what we were doing. We were supposed to find the constants a and b so that the function satisfies a differential equation. And the only way that function would satisfy that differential equation is if this stuff, negative 3a minus 3b is equal to 1, and if a minus 3b is equal to 0. And that's only true if a is negative 3/10 and b is negative 1/10. That's it.